Welcome to the second tutorial for the GenoPred pipeline, an easy-to-use, scalable software pipeline developed at King's College London which can be used to calculate polygenic scores. Okay, so in the previous video we showed how to install the GenoPred pipeline. Before we go on to running the pipeline, I want to briefly explain how the pipeline is configured, by which I mean how the user tells the pipeline what to do. There are 4 files controlling the pipeline's configuration. Firstly, there's the config file, which tells the pipeline what to do and where some additional configuration files are located. These additional configuration files are the target list, GWAS list, and score list. The target list is a file providing information about the target datasets, i.e. the samples that polygenic scores will be calculated for. The GWAS list provides information about the GWAS sum stats to be used for polygenic scoring, and the score list provides information about externally created score files also to be used for polygenic scoring. Examples of each of these input files can be found in the GenoPred pipeline folder. I'll now go through each of these files explaining what is going on. All of this information can also be found on the website. So first, the config file. This is a YAML file and is required for the snakemate pipeline to run. There are 7 parameters within the config file. First, outdir, which indicates where you want the outputs of the pipeline to be stored. Then, config file, indicating the location of the config file itself. Next, there's GWAS list, score list, and target list, indicating the location of the GWAS list, score list, and target files, respectively. Then, PGS methods, which indicates which polygenic scoring methods you would like to apply to the submitted GWAS summary statistics. And finally, the testing parameter, which is used to control some testing modes for the pipeline. This testing parameter is normally set to NA, unless you want to try running the pipeline using a single chromosome. Note, by default the pipeline reads the config YAML file in the GenoPred pipeline folder. When using your own data, instead of updating the default config YAML file, I would recommend creating a new config file and then telling snakemake to use that file using the configfile parameter. This allows you to use the GenoPred pipeline with multiple configurations. Okay, so let's talk about the GWAS list. It's a whitespace delimited file that has 9 columns and a row for each GWAS. I'll briefly describe these columns. So first, name simply indicates what ID should be used to identify the GWAS. Then path specifies the GWAS sum stats file path. Then population indicates the reference population that best matches the GWAS sample. If the GWAS is a mixture of ancestries, then I would suggest specifying the population that matches the majority of individuals. Then the column N is an optional parameter that can be used to specify the sample size of the GWAS if there was no sample size information within the sumstats file. Then we have sampling and prevalence, which are used for GWAS of binary outcomes, with sampling indicating the proportion of the GWAS sample with the outcome, and prevalence being the population prevalence of the outcome. These values are used to convert the SNP-based heritability to the liability scale, which is recommended for some polygenic scoring methods. Then we have the columns mean and SD, which are used for GWAS of continuous outcomes. These indicate the mean and standard deviation of the trait in the general population. These values can be set to 0 and 1 if they're unknown. They're only used when generating the individual level reports where polygenic scores can be viewed on the absolute scale. Finally, the label column is a label for each GWAS, which are used for creating plots in the report. These labels can contain white spaces, but should be within quotes to ensure the column is read as a single character string. The score list is also a whitespace delimited file. It has 3 columns and a row for each score file. The name, path, and label columns are the same as those in the GWAS list file. However, in the score list, the path column can indicate the location of the score file, or if the name corresponds to a polygenic score catalog ID, the path can be set to NA, which will trigger the pipeline to download the score file directly from the polygenic score catalog. Finally, the target list. This is again a white space delimited file. It has 4 columns and a row for each target dataset. First, the name column is an identifier for each target dataset. Then path indicates the location of the genetic data files. I'll talk about this more in a second. Then the type column indicates the format of the target dataset, such as plink1, plink2, bgen, VCF, and 23andMe. And finally, the indiv report column is a logical column indicating whether individual level reports should be generated for a given target dataset. So I mentioned that the path column specifies the location of the genetic data files. If the format of the target dataset is in plink1, plink2, bgen, or VCF, then the target genetic data should be split by chromosome, and the file name should have a full stop CHR and then the chromosome number written on the end, followed by the suffix of the file, such as .bed, .vcf, .bgen, and so on. Here are some examples of those formats. If the input genetic data is 23andMe format, then the path column is the path to the 23andMe genetic data that you downloaded, which can be zipped or unzipped. Okay, so now we've covered how the pipeline is configured. Check out our next video on how to run the pipeline.